Hello everybody, welcome back. All right, today we are going to be talking about graphing in Vertex form. And we did some of this yesterday, or previewed it a little bit when we were talking about how graphs can get wider or get narrower. So, warming up for what we did yesterday, let's talk about what are the transformations and what is our vertex. All right, as we're looking at this one, transformation, we've got a negative sign. That tells us this thing is flipped over. It normally face up, then negative, now it's facing down. We've got 4. Well, since 4 is greater than 1, this thing has gotten narrower. Okay? Inside the parentheses, that is our left or right number. Plus 3 means that this thing went left 3. Because remember, inside the parentheses, it acts the opposite as you would think. Outside the parentheses, that's our up-down number, and the sign looks exactly like you would think. -2 means down 2. So what is our vertex? Well, left 3, our x value went -3, down 2, our y value, -2. All right, this one here. Okay, now we've got a number that is between 0 and 1. It's smaller than 1 but greater than 0. That means this is going to get wider. Okay? Inside the parentheses again is my left right. Opposite of what I'd think, so this thing is going right 8. Outside the parentheses is our up down number. +1 acts just like I would think, up 1. So my vertex, right 8, my x value moved 8, up 1, my x value moved 1. All right, so just a quick review off of what we did yesterday. So here's what we've seen, right? We've seen vertex form. We have seen that h moves the parabola right or left, the opposite. K moves it up and down, exactly what you would think. If a is negative, then that opens up. If a is greater than 1, it narrows the parabola, or I should say the absolute value of a. Don't forget about those negatives. And if a, the absolute value of, let me erase that. If the absolute value of a is less than 1, then it's going to make it wider. Okay? Basically, any of those numbers between 0 and 1, or 0 and -1. Something that's smaller than 1 but bigger than 0. And again, we don't really worry about negatives and positives because we know negative just flips it over, positive just makes it point up. We're really just looking if that number itself bigger than 1 or less than 1. All right. So today we're going to do some specific graphing. And I know we did some of it yesterday, but I really want you guys to focus because I think this is going to really help you start to see some of these patterns as you are graphing. So here's what I'm going to have you do. Find the vertex. Point 1, find the vertex. Talk about the transformations. Use what we know about the parent functions and the transformations to find the vertex. You're going to make a t-table for each one with 5 points. Here's what you can do. Just put the vertex right in the middle. Put that vertex right in the middle. Then, as you're picking your points, if this point is, x, just say, well, this is x minus 1. That's x minus 2. So just pick the two numbers next lowest. And then pick x plus 1 and x plus 2. Pick those two numbers. Because if you start at the vertex, it makes this easy because with a parabola, those y values are going to all be the same. You'll want to double check them just to make sure, but it's going to help out and you're going to be able to use that mirror effect that parabolas do. Okay, plot all the 5 points and draw the graph. So let's just start. And again, I know we did this one yesterday, but let's start with something boring. Okay, well, not boring, but just something very like we know exactly what's going to happen. It is our parent function. We know our parent function has none as far as transformations because it's exactly what we're going to start with. And we know that the vertex is going to be at 0, 0. So that makes it easy for us. Here is our vertex at 0, 0. Oh, and if you remember what happened yesterday, I'm just going to pick 1 less, 2 less, 1 more, 2 more. Well, f of x is just -2 squared. Negative 1 squared. 1 squared, 2 squared. All right, so negative 2 squared is equal to 4. Negative 1 squared is 1. 1 squared is 1. 2 squared is 4. So we saw this pattern happening yesterday too. Well, let's plug these in. And it fits the over 1, up 1, back 1, up 1, over 2, up 4, back 2, up 4. There's our parent function. And you're going to start to see, let me zoom in even a little bit on here. You're going to start to see this pattern a lot with graphing parabolas. Okay? All right. So that was our nice easy one. We did it yesterday. Went through it kind of quickly. But let's try something a little bit different. Okay. So here's what we've got. Transformations. This is our left-right number. This means we are going right 4. This is our up-down number. This means up 3. So our vertex, well, right 4 means positive 4. Up 3 means 3. All right, so we can take these two things and directly put them right into the vertex. All right, and what did I say for vertex numbers? Just go 3, 2, and 5, 6. Just grab the 2 lower numbers and the 2 higher numbers. And let's start plugging these in. 2 minus 4 squared plus 3. 2 minus 4 is negative 2. Squared is 4 plus 3 is 7. All right. 3 minus 4 squared plus 3. 3 minus 4 is negative 1. Squared is positive 1. Plus 3 is 4. All right. 5 minus 4 squared plus 3. 1 squared is 1 plus 3 is 4. And 6 minus 4 squared plus 3. 6 minus 4 is 2. Squared is 4 plus 3 is 7. All right. So let's plot some of these points. Our vertex, over 4, up 3. Okay. Our next point, over 5, up 4. Over 3, up 4. Notice that same pattern's happening again. Over 1, up 1. Back 1, up 1. All right, let's check. Over 6, up 7. Over 2, up 7. Notice again that pattern. Over 2, up 1, 2, 3, 4. Back 2, up 1, 2, 3, 4. We are seeing the exact same pattern anytime we have the parabola without any number in front. Over 1, up 1. Over 2, up 4. Over 3, up 9. Not surprisingly, well, what's 1 squared? 1. Over 2, up 2 squared, which is 4. Over 3, up 3 squared, which is 9. You're going to see that pattern, okay? Well, that's if we're moving left and right. All right. You guys know this stuff. Domain, all real numbers is always true. When we're writing about range, if we have a minimum, if we have a low spot, it'll be y is greater because the numbers are going to be higher. If we have a negative number, we're going to have a maximum because it faces down, and y's will be below the line, so less than. All right, we can find all this. But just some good things to point out, just some nice tips to find. Axis of symmetry is just h. Let me find a different color than that. Axis of symmetry is always just going to be h. Notice that. Okay, the minimum and maximum is always going to be k. Let's notice that. Let's flip back up here. Axis of symmetry in this one is the one that's going to go through our vertex. Notice it was at x equals, I got to scooch it over a little bit, looks like it's at the 4, is at x equals 4, right? The maximum or minimum the line that cuts through here that says y is always going to be at or above this is at 3. Some good things to notice. All right. Let's do that, and let's fill these in as we take a look now. All right, transformations again. We've got, okay, nothing in front. This thing is not flipped because I don't have a negative. It's not wider or narrower. My left-right number tells me that this is going to be going left 1, and my up-down number tells me this is down 2. Okay, so here's what I know now. My vertex left 1 is -1, down 2 is -2. Well, what did we just learn? We just learned that it's not going to work. We just learned that vertex of -1 is also going to be our axis of symmetry. X is equal to -1. And we just learned that, let's try, this is probably not going to work. Nope. This is also going to be related to our range. That second number is going to predict our range. We know we're going to have something to do with y and something to do with -2. Let's graph it and figure out what the other part is. All right, so I need some more points. The other points, well, like I've been saying, let's just pick -2 and -3, and let's pick 0 and 1. We're just picking our vertex, putting it right in the middle, 2 points higher, 2 points lower. All right, -3 plus 1 is squared minus 2. -3 plus 1 is -2. Squared is 4, minus 2 gets me to 2. All right, -2 plus 1 squared minus 2. -2 plus 1 is -1. Squared is 1, minus 2 is -1. Okay, and I'm just going to fill them in. I would recommend for you guys to try them to make sure, but this is why I'm using the pattern. Okay, let's get these things plotted. Vertex, -1, -2, right there. All right, next point, 0, -1, and -2, -1. Over 1, up 1, back 1, up 1. All right, over 1, up 2, and back 3, up 2. Okay, over 1, 2, up 1, 2, 3, 4. Back 2, up 1, 2, 3, 4. All right, not surprising, but it's following our same pattern that we're starting to see over and over again. Our parabola is then going to come up like this. All right, domain, always the easiest one. Remember, all reals. We can use every x that we want. All right, our minimum maximum. Okay, well, the minimum maximum is basically that line right here. That's going to hit that bottom point. All right, we know it is at -2. Hey, we just use that -2 again. All right, range, y is something -2. Is it the bigger numbers than -2, or is it the smaller numbers than -2? Well, it's the bigger ones, so we're going to say y. All of the y's that I'm going to get on this parabola are going to be bigger than, or greater than, or equal to -2. All right. What about this one? Ooh, this one's a little bit different. We've got a number in front, right? We've got a number in front, so if I'm looking at my transformations, this is going to flip because it's negative. It's going to be narrower. And we are going to, that's my up, no parentheses, so that's my up, down. We're going to go up 6. So I don't have a left and right movement, so my vertex will be 0. I do have an up, down, so my vertex will be at 0, 6. All right, axis of symmetry, I already know it. Axis of symmetry is just my x-coordinate. We knew that, though. Remember when we used to find the axis of symmetry and then plug it in to find our vertex? So we know that if we have our vertex, the x equals 0 part is our axis of symmetry. We just did it the opposite way around before the last quiz. All right, and what else did we find on our last problem? We found that 6 is going to go both there and there. We know the minimum maximum is going to be a 6. And we know that the range is going to be y and have something to do with the 6. Okay. We may not be entirely sure. We might want to check about whether this is a min or max, but I think we can make a prediction right now, but we'll circle back to that in a minute. All right. What numbers am I going to pick? Well, I'm going to pick -1 and -2 and 1 and 2. Let's plug in. -3 times -2 squared plus 6 is equal to -2 squared is 4 times -3 is -12 plus 6 is -6. Remember to use GEMDAS. We got to square that before we can do the multiplication. So I get -6. All right, -3 times -1 squared plus 6 is equal to, all right, -1 squared is 1 times -3. So -3 plus 6 is +3. All right. And I'm just going to jot these down because I know they're going to work out the same way. All right, let's graph these. 0, 6. There is my vertex. Okay. Over 1, up 3. Okay. Back 1, up 3. Over 2, down 6. Back 2, down 6. All right, so I've got my graph here. And it's going to swing down on this side, come up and swing down again on this side. All right, so there is my parabola. It is narrower than our normal one, right? Normally, we go over 1, up 1, and if it was flipped, we'd go over 1, down 1, over 1, down 1, over 2, down 1, 2, 3, 4, over 2, down 1, 2, 3, 4. Normally, we'd be out here somewhere for our parent function, but we're narrower, right? Because that number is, the number itself is bigger than 1. All right, domain, easy points, always all reals. Min max is 6. All right, well, that checks out from what we saw in our graph here. This isn't going any, it's all on one side of the 6, so that must be good. All right, now our range. Let's go back to our range. Do we get the numbers bigger than 6 or smaller than 6? All of these y's that I get down here are smaller than 6, so y is going to be greater than, less than or equal to 6. I'm getting all the numbers that are less than or equal to 6. Now, how would I have known that this was a max before I even started? Because it's negative. When it's facing up, we're going to have a minimum because we're going to have the smallest spot. When it's facing down, it's going to be a maximum because we're going to have the highest point. Okay? All right. Last problem before I release you into your assignment. I just want to show you one more. Okay, we got this. It is going to be flipped. It is going to be wider because 1/2 is between 0 and 1. We are going to go left 2 because inside the parentheses I have a +2. And we're going to go up 5. So our vertex, left 2, that's -2, up 5 is 5. So let's go -3, -4, -1, 0 are the points we should pick for our x. All right. -1/2 times -4 plus 2 squared plus 5. -1/2 times -3 plus 2 squared plus 5. All right, -4 plus 2 is -2 squared is 4 times -1/2 is -2 plus 5, 3. So that must be 3 as well. Okay, and -3 plus 2 is -1. Squared it is 1. -1/2 times 1 is -1/2 plus 5, 4.5. 4.5. All right. So let's get these. Well, wait a minute. Hold on. We know some stuff about this graph before we even start. X value is our axis of symmetry. So x equals -2. That will be our axis of symmetry. We know 5 is going to be our max min value, and we know it's going to have to do with our range. Okay? And here, I think we can even make some reasonable estimates. We can say that 5 is going to be a max value. Why do I say it's going to be a max? Well, remember, it's negative, so this is going to face upside down. Since it's negative, it'll face upside down, so I know that that must be the highest point. Range, okay. Y and 5, here's my educated guess, and we can come back and check it. Since I know this is going to face upside down, I'm going to get the y's that are less than or equal to 5, because I'm going to get those y's that are below 5. All right, let's give it a shot. Let's see if my predictions, and domain all reals. Let's see if my predictions are going to come true. -2 up 5. Okay. -3 up 4.5. Right there. Or -1 up 4.5. Okay. 0 up 3. -4 up 3. All right. So my axis of symmetry does hit right down -2. And the graph of our function is flipped. It's facing downward, just like we predicted. In that direction, our normal graph, over 1, down 1, over 1, down 1, over 2, down 1, 2, 3, 4, over 2, down 4. It would be inside of this, so we were definitely correct on wider. And let's see. Our top value is right there at 5, so it is definitely a maximum. There's nothing higher than 5 on this, and all of our y's are going to be lower. All right. A lot of stuff there, but I think you guys got it, especially coming off the last couple of days. So work through this. Again, utilize my office hours. Feel free to send me emails. Feel free to send me Schoology messages.